Good morning, everybody. I think we'll get started now. I think most people have joined. My name's Paul Brett. I'm responsible for Cubro's business in the UK, Ireland, and Middle East region, and I'll be your host for the webinar this morning. I'm joined by Herbert Ettlinger. Herbert's one of the founder members of Cubro and is responsible for our technical teams. Excuse me. And actually, it'll be Herbert that will be covering the majority of if you like, the meat of the webinar today. Just a bit of housekeeping, I guess. We're scheduled for about 45 minutes. If you have any questions, please feel free to ask those as we go in the chat section. We'll have a number of questions and polls that we'll publish throughout the webinar. We really appreciate your feedback on those, and there's a number of resources and handouts that you'll be able to download. In terms of the agenda today, I'll start in just a second, really to give you a very high level appreciation of what we see as the value of network visibility solutions, sort of gleaned from our sort of 20 years experience in the business. I'll then hand over to Herbert, and as I say, the majority of the time will be for Herbert to take you through the more detailed aspects of what network visibility is, why it's required, what the challenges are, what the use cases are, and how to build those resilient network visibility solutions. I'll come back at the end and summarize, and we'll have a Q&A session at the end for those that have questions that they prefer not to ask as we go through the webinar. So to start in terms of the value of network visibility, I'll come to that in just a second, actually, but maybe I'll just start very quickly to really add some context around that. What's the environment that network visibility solutions are operating in, and why are they needed? So obviously, they're deployed in modern networks. Modern networks are typically complicated, complex overlay architectures, and they operate in multiple environments. Whether that's physical, whether it's cloud, whether it's some type of virtual environment. They typically support multiple media types and application types. So, for example, voice, data, video, all of which have different performance characteristics. They're typically high performance and high traffic loading, and that continues to increase and accelerate over time. And then finally, they need to be managed. They need to be managed to make sure that they're working correctly, performing correctly, to make sure that they're secure, to make sure that they have all of the right resources and capabilities required to deliver services, so around planning and capacity planning and so on, and to make sure that they are compliant to any relevant standards or policies, whether those are internal policies or industry standard external standards of some type. So those are some of the most relevant aspects of modern networks, and then the challenge, of course, is being able to manage that. And they're very complex environments. So the first challenge is actually just getting access to the relevant network traffic to be able to analyze it, to then be able to manage those different aspects of performance, security, and planning, and so on. The second challenge is that there are then typically multiple use cases that need to be delivered against, again, performance, security, analytics, across those different network types, and delivering, or those use cases being delivered typically by different network tools. Network tools are the devices or we're named for the devices that we use that are used to manage those networks. So typically there are monitoring devices, there are security devices, and analytics devices as well. And because of all that complexity and challenges, that tends to have an impact on cost. And the cost of network tools and the cost of management has increased over time as well. Final point, I guess, is as those networks are becoming higher performance with greater loading, greater capacity, the network tools capabilities need to grow in line with those to continue to be able to manage those environments. So those are just some of the highlights, I guess, of some of the management challenges. I guess these aren't exhaustive lists, but really just a very high level snapshot. We have very complex network environments and a great number of challenges to be able to manage those. And that's where network visibility comes in. And the value that network visibility solutions provide is to help with the ability to manage the network performance, so help to improve the network performance, help to improve network security posture, help to improve capacity planning and standards compliance, while at the same time reducing costs. Again, that's a very high level snapshot of the visibility, the value of visibility solutions. And what network visibility solutions do to be able to deliver that value is to observe that when they connect to networks and observe all of the traffic crossing the network, they're then able to duplicate the relevant network traffic that needs to be analyzed by those network tools. We can then optimize that duplicated traffic and provide that optimized duplicated traffic as data feeds to the relevant network tools. Two of the key, again, high-level capabilities of network visibility solutions to deliver that value and those operational capabilities is firstly to provide access to all of the relevant network traffic to the network tool. So as a subcomponent to that, we're able to remove network blind spots. All networks have one or a number of blind spots, and what we mean by a blind spot is network traffic that is not understood by the network tools. That's typically for legitimate networking purposes. They might understand certain protocols or certain tunneling protocols, for example. The network visibility solution does understand that. It is able to remove those protocols and deliver the native traffic, or the relevant native traffic, to the network tools. We can also get access of the network traffic from those different network environments as listed there as well. And we're able to deliver the traffic for those multiple use cases. The second key high-level capability is that again, network visibility tools are able to reduce the loading. Network visibility solutions are able to reduce the loading of network tools. Because as I mentioned above, network visibility is able to observe all of the traffic and then duplicate the relevant traffic. Part of that is that we also filter out traffic that does not need to be analyzed. So what we're able to pass through to the network tools is the minimum quantity of traffic to carry out their function, but that retains all of the value of that traffic. So that reducing of the loading has a direct impact on the CapEx, on the cost of those tools, and therefore on the operational cost, on the OpEx, and also helps to extend their life cycle as well. And the second, again, operational benefit of that is that by reducing the loading onto those network tools, that reduces the quantity of traffic that the visibility solutions, or the network tools, I should say, have to analyze, which allows them to operate more efficiently, more productively, means that they have less traffic that they have to analyze to identify potential network problems, so reduces the time to find potential network problems. So that's a very quick snapshot and a precursor, if you like, to the value of network visibility solutions and the environments that they're operating in typically. So I'll hand over to Herbert now, who can take you through more of the detail, and I'll come back at the end to summarize and move to Q&A. So Herbert, over to you.
Yeah, perfect, Paul. Thanks for the introduction. Yes, this is Herbert here. Paul mentioned already many points. Some of them, of course, we will elaborate a little bit and take a look into the details. Also, you just have seen the poll question in the webinar, and very interesting answers that you are dealing with complex network setups. It's a lack of visibility, and all these things I'm going to address now. Okay, so let me share my screen. Okay, so if everything goes well, yes, here we are. Okay, good. Right, as I said, I mean, this is my name here, Herbert Ettlinger. I'm the head of product engineering here in Cubro, based in Vienna. Okay, and I walk you through now some more technical details. So once you have questions, as we said, you can also use the chat, and we are trying to answer that online. Right, about the content, what we are doing, what we are going to do. So we'll talk a little bit about networks, what are the challenges, what means network visibility. We'll talk a little bit about network packet broker, what it is. also what we will do, we will talk about these complex networks. We'll talk about tunnel traffic, how you could handle that, what issues we are facing. And also, I'm trying to make a live demo. There's always a kind of certain risk, to be honest, if everything works well. So now I tried it 100 times, of course, in preparation. Every time it worked. So let's see if also during the webinar. Okay, so these are the points we are going to discuss. Right. Look, what we see typically in the last years and since beginning of Cubro is there's on the one hand, you have the network. Network, there's different, for example, port speed, interface speeds, different kind of media, optical fiber, copper, 10 gig, 40 gig, 100 gig, 400 gig. Then you also have, we see more and more tunnel traffic that comes out from cloud, which comes out from virtual environment. That means we are dealing not only with classical IP version 4 or maybe IP, uh, there's a message. Okay. You can all see the screen, I think. I hope so, because I got some error message here, but I think it should be okay. And that means we are not only dealing with standard packet types, also we see a lot of tunnels. This is something we also have to consider. Of course, different technology, it's like there's still bare metal, of course, there's virtualization, cloud infrastructure. And this is the one, on the one hand, this is the network itself. And on the other hand, we have monitoring or analytics. There's different tools like capture, like security tools, customer experience management, and all these tools usually have different requirements. And network and monitoring tools as could be seen as different entities. And what we see also, there's a gap between them. Of course, so network is evolving, also monitoring is evolving, but sometimes not as fast as network. And what we do, or what network visibility means, is on the here on bottom, you have the network infrastructure, different technologies, as we said, and on top here you have your monitoring tools, like security, capture, or whatever. And in between these, this is where Cubro is based. What we do actually is that we actually give you the access to the data that are needed by these tools coming from the network. So we keep the monitoring layer and the network layer separated. So we are sitting in between. And key point also is that we forward information to the tools in the right in the correct way to the monitoring tools to make really efficient use of the monitoring. It doesn't make sense maybe to give all the traffic and everything to the monitoring tool because maybe this will overload it. But just what you really need, that everything is there in the right format, so to say. This is what network visibility is. And the typical problems, challenges we see, this is just a summary of some of them, is some of them are very evident, let's say, is not difficult to understand, is, for example, that when you have probe or analytic system, of course, it has certain amount of physical interfaces. So usually it's not possible that all your spanning ports or splitter ports are connected directly to the probe. Sometimes you need a device that aggregates traffic in front of the probe. So to take more inputs and have maybe only one output, called aggregation. So this is one of the easier things to understand. So yes, use aggregation. Of course, sometimes interface speed of the network, let's assume it's a 400 gig network. So we are copying the 400 gig network. Then we cannot feed directly the 400 gig interface to the probe because probe maybe only is 100 gig or only 10 gig or 25 gig. So what we need to do is maybe we need to filter out traffic to make it less. Of course, to aggregate more inputs to one or more outputs, and also do load balancing. Load balancing means to distribute the traffic to the probe in a meaningful way, which we will see later on in a little bit more detail. Also, very often, same information is arriving twice. So you have the same packet or the same piece of information, it's going to the probe maybe in 2 copies, 3 copies, that could be a problem. Of course, will overload, doesn't give any additional benefit in terms of analytics, let's say, but maybe even on the other hand, it gives you wrong alarms. So one thing is we need to consider is, for example, deduplication, just to remove unnecessary copies. And then this point we will maybe take a look a little bit longer, is the traffic is sometimes mirrored out. Maybe it's inside an active tunnel. So when you have, for example, some virtual environment and you need to mirror out the traffic, it's inside the tunnel, it's inside the GRE tunnel. Of course, this tunnel, you need an active counterpart. This can be the probe, but can also be another device, a visibility device like a packet broker, to just take this tunnel and take out the data from the tunnel. And also, very often, this is one of the major issues, is that the traffic is what is needed is hidden inside the tunnel. So if there's tunnel, which we'll see later on, maybe the information we are looking for is not visible in the first view, so to say, and we need to look deeper. So these are some of the typical issues which we are trying to address. And some of them you will see a little bit in more detail later on. So one of the key products is to achieve all these things, to do filtering, load balancing, aggregation, maybe do something with your tunnel, is the network packet broker. What is network packet broker? Is like a physical switch-like device. And actually what it does, it maybe you could see it's like an intelligent distribution panel. So it is connected to the network. It gets all the network traffic and then distributes it, yeah, to the requirements of the analytics as we see here. Yeah. So maybe analytics tool number one needs only some certain traffic, then we filter that out and only feed this one. Yeah. Another system needs a little bit more traffic, not only the green one is seen in the picture, but also red one. Yes, we will prepare for that. That is actually a network packet broker, which is one of the key devices for the network in the network visibility. Of course, we have tapping, let's say physical tapping, just to get access to the physical fiber or copper links. Of course, still very, very important. But usually afterwards, it's the heart of the visibility is a packet broker. So let's take a look to some typical applications, what the network packet broker is used for. And that's just a typical scenario, means we have a network. Okay, we want to access network traffic, then can happen via spam ports. We as a Cubro, of course, as a supplier of tapping and then splitters and then this kind of stuff, of course, we are never in favor of mirror ports or spam ports, but sometimes it is required because otherwise you cannot feed out the data. So, right, but usually, okay, there's also taps. We are getting network traffic, we are getting it to a packet broker, and what the packet broker is doing, it's having many inputs, but maybe only one output, because there's only one, here in this example, intrusion detection system, for example. So we do some aggregation. Of course, we do filtering. There's certain traffic that is not of interest to IDS. Maybe in the night, there's running backup traffic in the network, and this would just overload the IDS and is not required to be analyzed. Okay, so we do the aggregation, we can distribute the traffic to one or more outputs, of course. We also have a speed and media conversion. Let's assume it's 10 gigabit here speed, but IDS manager is maybe only 1 gig interface. So we also do this, of course. And very often, particularly when talking about spans, then maybe the traffic is coming out in tunnels. So we can, of course, remove the tunnel because IDS cannot handle tunnels. It's even maybe even makes issues. So what we are doing here is then we try to eliminate the blind spots, of course. Meaning we have high port count, we can take many data sources, feed it to one output. and so on. Remove the tunnels, do the filtering. So that's a very typical example. Also, what we do is load balancing, and load balancing. I just made this slide here. What means load balancing? Load balancing means distribute the traffic in a certain way, and very often key requirement is that we do session aware load balancing. What is session aware load balancing? Session aware load balancing means that all packets of a session, IP session or IP TCP session, always goes to the same probe, so that the session itself is not splitted apart. That's very important for most of the probes, because then the correlation, so to say, is much easier, and it's less workload for the probe. Not that we have to talk to many probes and find all the packets and pieces of information which belongs to one flow. So we are trying to keep every flow together, so to say. This means session aware load balancing, and that's usually a function of a packet broker. Later on, we'll see some examples what to consider, but just as a keyword here. Of course, we mentioned already, yes, what happens is very often that information is the same information, same packet even, or same content of the packet is arriving several times to a packet broker. Yeah, we could of course forward all these copies, but sometimes even security probe will have an issue to getting 6 times the same copy of the same, meaning it's getting overloaded, and sometimes even gives the wrong alarms because of that. So packet broker, or some of the packet brokers, they can also do deduplication, meaning when you see here information A arrives here but arrives maybe again at another port because you tapped it again or it's mirrored out several times. What we do, deduplication, is to only give out a single copy of it. Okay, not to be causing issues here at the security. So now going one step further about tunneled traffic. What means tunnel? Here on this side, you see example of Wireshark. I mean, this is a Wireshark capture file of DNS traffic. Okay, DNS, you get it in Wireshark, you can decode it, you can read it, everything is perfectly okay. It's an IP version 4, you see the IP addresses, you see your port information, it says 53, stands for DNS, it's also decoded. Everything fine, perfectly okay, no problem at all. But what happens if this is inside a tunnel? The tunnel usually is just in front of that. In front meaning that this information is not visible directly because it's inside the tunnel, and would look like this. Here's an example of a VXLAN tunnel. VXLAN tunnel means here on the original here if you have the original packet with your MAC addresses, which is coming from here, IP addresses coming from here, TCP UDP, it's coming from here. But in front of that, there's another MAC address, there's another IP, there's another UDP, and there's also a VXLAN identifier. Meaning, when you look at the packet, just looking at it, what you see is, yes, you see the IP address here, but this is the IP address of the tunnel. It's not the IP address of the user information, so to say. So very often happens, or always happens, we have to say, is that information like, I'm interested here in this part here. I want to filter DNS. DNS I can easily filter out using here port number 53. But when I look at the packet now, no, it's not visible directly. What do I see? I see IP, but this is tunnel IP. I see UDP port, but this is the VX tunnel port identifier, for example. And this is what I see. So the 53 is not visible just like that. That's the one of the issues with tunnels. So packet becomes bigger, of course, yes, and the information I'm interested is hidden. And this is just real world example. What we just taken is mobile operator. It's here. It's diameter traffic, but what we see is here is one tunnel. It's an ER span tunnel, and Inside the ER span is a VXLAN tunnel, and then is only the information of interest. So the packet is coming from a cloud environment, which does the VXLAN, and then is mirrored out by a switch, and this is then ER span. So two tunnels in front of the information I really want. Okay, so right, this is the Wireshark will decode that, but if you want to filter, yeah, it's complete. It's a different story. Yeah? Okay. Another point to consider when talking about tunnels is, in order when you have here, for example, you have your cloud environment or virtual environment, and you want to get the data out, you set up a mirror instance on the equipment. Yes, but this is active. This means it has an IP address. This is the tunnel IP, so to say. And then, of course, it needs an IP destination where to send this data. Yes, it should come, for example, to the packet broker. So packet broker also needs to have an IP address so that this tunnel becomes active and data are flowing here, or data from IP2 coming here and going here. So you need to have an active device. Okay, set up, give it an IP address. Otherwise, the information will never come to you. Okay, so also to be important is that you have possibility of not only passively receiving traffic, but also actively, meaning terminate the tunnel. Okay. Very often what we see these days is, when talking about tunnels, is that very often there's also probes out there, an analytic system, they can also handle the tunnel, but usually very complicated to set up, or they are limited by the number of tunnels they can terminate. And what I mean is that the solution we have is that, yes, we can receive tunnel, but without setting up the tunnel. So what do I mean with that is, for example, that's a typical example, and it's of a Cubro packet broker, which you see later on, of course, also live. It says here tunnel strip. Tunnel strip means it removes the tunnel. Okay. You see just VXLAN or GRE or AirSpan or whatever. And important is, you don't need to set up the tunnel itself. You can, if you want to specify one specific tunnel, you can. But if you're not interested in the tunnel itself and its parameters, then you don't have to. In many other products, you have to specify the tunnel always, and that's very tricky. So if you have one tunnel, no problem. But if you have 10 tunnels, 20 or 100 tunnels, that means you have to set up every tunnel. And very often is, you need to set up all these IP addresses. You need to set up the MAC addresses. So once you have more tunnels, there's a huge danger of misoperation. And what is even worse is that you don't even know the tunnel parameters, because maybe set up by network people. And maybe, or very often happens, these parameters are changed. So when you have tool and you're looking for a tunnel, but somebody else changed the tunnel, yeah, then you're blind. That won't happen here, because we are just taking a look. Aha, this is tunnel information, so we just remove it. Not important to us. Okay, good. So now we have heard a lot about tunnels and so on, and let us try to make some examples of that. What it really means. Okay, so let me change my display now. Yeah, as we said, it worked very often in this testing in the last days. We'll see if it also now works. Okay, so let me close that. And now we should go on. I should show you the demo setup. Sorry, yeah, this one. Um, this is the demo setup I'm using. Just a moment. Yes, right. So I'm using here, this is 400 gig packet broker. Okay, so it has 32 ports. Every port can do 400 gig, or every port can be used for 4 times 100 gig. That's not important in this case, but just that you know. And what I'm doing is, I have here so-called playout. Playout means I can replay capture files. It's just for my testing. It's test traffic. And I have a playout file One is ER span encapsulated and another one is GR encapsulated. You will see, of course, I will show you. And it what I have, so this is my inputs. I have two inputs, and then I'm using here a port as output. And this port actually, I will, oh sorry, I will do a load balancing test using two interfaces of a capture appliance. Okay, so it's two receivers, so to say. This is the one test, and we do another test on another capture interface, and here we do a filter test. Okay, this is what we do. Good. So just that you a little bit understand is there's a load balancing test we do, and we do a filter test. Load balancing test using two interfaces, filter test using another interface of the capture device. Okay, right. And now we can go to the live equipment and set up everything. Good. Okay, so first of all, this is the box. Okay, let's log in. That you see, it's nothing is configured. Okay, we will do everything together. Let me just log in. Yeah, okay, so at least this works. Perfect. Okay, look, what we see here is I have two input interfaces. This is interface 1 and this is the interface 3. So here we come with ER span and here we come with GRE. And this is the output interfaces here. You see three of them because this interface has been splitted. Then it looks like this. And I'm using interface 1 and 2 for the load balancing test, and the 3 I'm using for the filter test. So let us just quickly set this up. And we usually always work with forwarding policy. Forwarding policy means here you can define what you really want. So let's do this. So you see it's empty because of course, brand new unit. So we start from scratch. I say here plus, and I say, this is my input. Okay. So all the traffic that comes at, that comes at port number 1 is my input, so to say, and my output, I want two interfaces, this one and this one. So then I can decide how should they work, and I say, yes, I want to have them load balanced. So I want that all the input traffic is load balanced to the two outputs. And just say confirm, and that's it. And then you see this little arrow in the middle of the screen. If I click on that, I can tell the unit what traffic I want to load balance. And of course, to make it very easy now, we say everything. And how I make that, I see here add rule and add rule. And you see here a parameter like source IP, destination IP, protocol, source port, and many, many others. But I will not fill that out. If I leave it empty means everything. Okay, so this would be a kind of filtering, but I don't want to use filter, so I don't fill it out and say confirm. Okay, good. So we are done. Actually, yes, we are done. Our setup is ready. So now let's play the capture. Okay, how does it look like? So first of all, I should show you, this is my input traffic. Make it a little bit bigger for you. And what you see here is 20 packets, 20 packets, and there's 5 packets where the source IP1 talks to 11. Then there's 5 packets, 11 talks to 1. Then there's another 5, 2 to 12, and 12 to 2, another 5. So actually, this is the first 10 packets is one session, 5 packets in one direction, 5 packets in the other direction, and then you have 2 to 12, and 12 to 2, it's another 10 packets. So basically here, I'm simulating 2 sessions. Okay, session 1 and session 2. So this will be my input traffic. Okay, so let's try it. So now I will open the two capture interfaces. So what you see, let me organize a little bit. You see here capturing the interface 1 and capturing from interface 2. Okay, is empty at this moment because traffic is not running. So let us run now traffic. Okay, so this is a packet player. So this will just replay the capture file you saw before with this 1 to 11 and 2 to 12. Okay, just checking. Yes, this is the right file. Good. I say play. Oh, and you see, okay, on capture card number 2, I have received all the traffic, but I haven't received anything on 1. Hmm. I thought if I have load balancing, I would have expected that 1 to 11 goes to one interface and 2 to 12 goes to another interface. But it did not happen. And the reason is, I'll show you, is when I take a look on the package itself, what will you see? Okay, take a look to the packet. Here we have it. I'll make it a little bit bigger that you see it. You see here, this packet is in a tunnel, is ER span. You see here the outer tunnel. This is the IP address of the tunnel. And then inside, you see, the 0, 1 to 12. But it's, so to say, it's hidden. It's not displayed here in the first place with a Wireshark on top. Wireshark on top doesn't display that this is a tunnel. But when you look into the packet itself, you see, this is ER span. And how load balancing works in this moment is it uses the outer IP addresses for load balancing. Outer IP addresses means the tunnel IPs, which is here. This is the outer IP, so to say. But when we move through all the packets, hey, you see these outer IP addresses is never changed because all these packets are coming in the same tunnel. So the load balancing, which is based on IP addresses, doesn't work, of course. Okay, so that's the issue here. So, but what can we do now? I mean, super. If this is everything in the same tunnel, load balancing doesn't work. So let's repeat the test again. So, okay, run it again. But before, let's go back to our configuration. Configuration is still there. So we open the ingress interface and there's a port config. And what you can do now is there's the so-called load balancing mode here. I can say, but I'm not interested in tunnel outer layer. I can say, use the inner layer, confirm. Okay, we are done. So, and then repeat the test. And now let's see what happens now. Okay, so here's again my playout. I say play. Wow, look at this. Now it looks perfectly okay. Because what do we have? We have 2 to 12, 12 to 2 on interface 1, 1 to 11, 11 to 1 on the other interface. So first of all, load balancing is working and also it's session aware. So all the data from the one session goes to one side, to the Ethernet 1, interface 1 in our case, and second case, 1 goes to 11 goes to 2, and 2 to 12 goes to 1. Okay, so now we have nice distribution. And this is because what the difference now is, I'm using the inner IP, the inner tunnel IP for the load balancing. And then I have nice distribution. So without these possibilities, and you have the tunnel, yeah, I'm sorry, this is very bad news. You need to have this possibility. Of course, at the same time, let me redo the test. All right, start again. What we also can do, if I go back to my configuration of the packet broker, I can say port configuration. I can say, hey, but airspan, I'm not interested in airspan. Maybe the airspan, is not required for my analytics or for my tool, so I can remove it. Okay, request success, super, very good, everything done. So we repeat the test once more. Right, here we are, and we say play. Of course, still 10 packets on each side, perfectly okay. Um, but if you look now at the data here, you see there is no airspan anymore. I removed the airspan. And that's really cool. So by just 2 mouse clicks in a load balancing, remove all the tunnel, we are done. So it's gone now. So this was the first test about tunnel traffic that sometimes uh, could be really difficult. Right. So let's close this and just coming to an end and make another example. So we don't need that. We don't need that. Good. Another example. Let's go back here. So let me delete this. And now let's use the interface number 3. This is the GRE interface. So let me just first delete this. Okay. Make a new forwarding policy. Okay. Take the interface number 3. Input, and here also take this interface here, number 3. Okay. And this is now a filtering scenario. And what I wanted to do is, let me just open the capture file first. This is here we are. Yes, let's open. So this is actually my input. You see, there's many packets, whatever it is. And what I want to filter out is DNS traffic. I see DNS. Okay, Wireshark says, yes, there is DNS traffic, perfectly okay. And at the very bottom, I don't know if you can see, is about 75 packets we have. Yeah? 75 packets is DNS traffic. And these I want to filter out now. How can I filter the DNS traffic? I can use port number 53. Okay, port number 53, this is the definition of DNS in my case here. So what does it mean for my configuration? Yes, again, I want to do the filtering now, but I see here add rule. But what do? I see here port 53. Okay, I can add another rule, and also I want both directions. Okay, so 53 as the source and 53 as the destination, and just say confirm all. Good, perfect. So it should work. So let's give it a try. And let me open another Wireshark. So, okay, let me open interface number 3. So this is my interface number 3. So here I would expect now only DNS traffic. So let's run it. Okay, I say add file here. So this is my file, and I say play. I say play. I say play. I say play. Hey, nothing is coming out. Somehow must have an error. Yes, I made an error, of course. And if I open again the file I'm sending and I'm taking a look to the packets, what do I see? I see tunnel here. It's GRE tunnel. Yes, port 53 is there, but it's inside the tunnel. So how can I solve that? I go back to my configuration. I go back to my input interface. I say port configuration. And what do I say? I can say ingress filter mode on top here and can say tunnel inner layer and not tunnel outer layer. Okay, success. Just one try. Capture is open. We play again. Look at this. Now the information is there. And it's on the very bottom, you see here, sorry, see here, 75 packets. Yes, this is the result. Okay. So that's is also the good feature, so to say, to filter inside the tunnel. Okay, how important it is. And that becomes more and more important as we see. Good. So this is for the live demo. So you've seen it worked. And we are running out of time, I see. So let me just quickly go through here and making the points. Yes, key points. And that we see very often is, yes, we require inner tunnel filtering. We require tunnel removal. And also we require load balancing, session aware. But again, inside the tunnel, not for the outer tunnel. Outer tunnel doesn't mean anything. Right. Okay, this is the displays you have seen. I'm not going through anymore. Right. And this just brings me to the end, and then I hand over to Paul. Is about This is a very complicated slide, to be honest. Yeah, I made it, but I don't like it because there's so much, a lot of information there. But what we do actually in Cubro for the packet broker is there's a really huge range of products, and it's always different by the physical interface speed we support. We have units for 400 gig, but also there's more for 10 gig focus, 100 gig focus, and different capabilities. So if you have your requirement, please talk to us. Yeah, I think there's always find a good solution. Right. So this is my summary. Okay. Yes. One thing at the very end, last sentence is what you have seen today, this load balancing, that actually is done in hardware. It's not done by a CPU, it's done on ASIC. That means this works for terabit per second. It's not just for a few megabit or maybe 100 gig or 150 gig where they have CPU limit. No, this is done in hardware. And that's quite something. Yeah. Right, guys. So, Paul, let me hand over back to you. Sorry, I took most likely too long.
That's fine. Thanks.
Right. Okay.
Herbert. So I guess just to summarize, network visibility solutions cost effectively provide optimized data feeds from multiple network technology types and environment types, as I mentioned before, on-premise, cloud, virtual environments, and so on, and provide those optimized data feeds to one or a number of network tools. And that allows the tools to successfully execute a number of network management use cases. And the value of that and those use cases are that we can help to improve network performance, help to improve network security posture, planning, and standards compliance. We're also able, obviously, to remove blind spots to provide access to all the relevant network traffic, which also, obviously, is a capability to help deliver that value. And we're also able, because we're able to optimize those data feeds, reduce the loading on network tools, we're able to help reduce CapEx, OpEx, and extend the life cycle of those products. I mean, just as an example, actually, one of the slides that Herbert put up there early on was for one of our customers who had Trellix IDSs. A combined Cubro Trellix solution was around about 50% of the price of a Trellix only solution. So those savings can be very significant. So that's everything I was going to cover on the summary. Hopefully you found the time useful and interesting. And we'll move now to Q&A to answer any outstanding questions. So my first question probably actually is I just want to make sure we've answered all of Alexander's questions. I noticed there were several there, Alexander. Do you have any other questions you'd like us to answer? And obviously, are there any other questions from anybody else? Okay, that's good. So I think we've satisfied Alexander. That's good. Thanks for the questions. Any other questions or any other points or comments anybody wants to make before we close the call? You're welcome, Chiara. Okay, I guess unless anybody else wants to make a comment, I guess we're probably in a position to close the call. Again, finally, just thank you very much for everybody for attending this morning. We appreciate your time's busy and in demand, and we really appreciate you spending some of that time with us this morning. Obviously, if at any time you need any more information, please get in touch. And I think this session is available to download, or a recording of the webinar is available to download as well. So thanks again, and hopefully we'll see you on the next one. Have a good day.
Yeah, thank you all.